2013, the Dutch water board Vallée and Veluwe shortlisted 5 consortia to provide a solution for converting the existing wastewater treatment plant at Amersfoort into an energy-autonomous facility, including the production of a commercially attractive fertilizer. The Dutch company Eliquo Water and Energy was awarded the contract for the design and realization of this new facility, based on most economically advantageous tender evaluation criteria. Sewerage produced by Amersfoort and the surrounding area is biologically treated in the wastewater treatment plant. The treatment process is carried out in large tanks, where various steps of sedimentation and aeration take place. The treated water is then discharged to the nearby river without any negative impact on the environment. Sludge is produced during 2 sedimentation phases of the treatment process. In the Netherlands, the agricultural use of sludge is strictly prohibited. Therefore, sludges must be incinerated in dedicated facilities. The cost of transportation and incineration of sludge is high, and valuable resources, such as energy and nutrients, are lost during the incineration process. Sewage sludge is also a valuable source of energy, which can be generated from the methane gas produced during the sludge digestion process. Eliquo developed the proprietary technology LysoTherm, which improves the effectiveness of this digestion process, leading to significantly increased production of methane gas compared with conventional systems. All methane gas produced by the Amersfoort facility is currently converted into electricity using 3 combined heat and power units. These CHP units produce 1,500 kilowatts of electricity, sufficient for the energy-autonomous operation of the entire treatment plant, as well as providing green electricity for an additional 600 households. The LysoTherm process uses high temperature and pressure to treat sludge. In a 2-stage heat exchange process, sludge is continuously heated to a temperature of 160 degrees Celsius. After heating, the sludge remains under pressure in a reactor, where its structures undergo cracking. This results in improved conversion of organic matter into methane gas during the digestion process. LysoTherm is supplied with clean-in-place equipment, LysoClean, for automated cleaning of the system, similar to that used in the dairy industry. Eliquo found that dairy products and sewage sludge behave in much the same way when heated, causing scaling and blocking of equipment. LysoClean prevents this, significantly increasing the reliability of LysoTherm by providing regular automatic cleaning of the LysoTherm modules. Since LysoTherm improves the efficiency of sludge digestion, it also enables the existing facilities to process sludges imported from 2 nearby treatment plants. The sludges are thickened prior to treatment with LysoTherm. As a result, the volume of sludge is reduced, allowing efficient dimensioning of process equipment. Water separated during the thickening process, as well as water resulting from the dewatering process, contains valuable phosphate and ammonium. These nutrients are recovered by Ostara's Pearl process. Adding small amounts of magnesium during treatment in the Pearl reactor leads to formation of crystal green fertilizer. The crystal green fertilizer is harvested from the reactor and, after drying, sieving, and packaging, is distributed to end users worldwide. Crystal green is recognized as a high-quality fertilizer marketed to the turf, horticultural, and agriculture sectors. Eliquo facilitated the crystal green offtake contract for the water board, guaranteeing a stream of fixed financial revenue over many years. Currently, the following benefits are realized. Sludge structures are cracked in the LysoTherm process, resulting in improved conversion of organic matter to biogas. At present, more methane gas is produced compared to yields prior to the installation of LysoTherm. More energy is produced, allowing energy-autonomous operation of the entire wastewater treatment process. The Pearl technology is used for the production of crystal green, an environmentally friendly fertilizer. The volume of sludge for disposal is significantly reduced, providing a substantial saving on the cost of transportation and incineration. Finally, a surplus of heat is also produced, which will allow the water board to further reduce the amount of sludge for disposal by using a low-temperature sludge drying process in the near future. The increased energy performance of the entire facility, as well as the significant savings on sludge disposal costs, result in a return on investment of less than 7 years. Moreover, the water board is also now achieving their set goals of improved energy performance, reduced carbon footprint, and recovery of valuable resources from their waste streams.